Welcome to my channel. So let us discuss the rules of differentiation. So there are several rules, or 8-9 rules of differentiation. We'll discuss one by one. Here we'll discuss the rules only, but the synthesis or analysis, the proof, the bionomical expansions will be available in PDF, because in the short video, so everything is not possible. So let us discuss the rule 1, the power function. If the function is in the power form, say let y is equal to x squared, that means y is the function of x, and the form of the function is y is equal to x squared, it is a power. Now dy by dx, simply dy by dx of the function, that the true function is x squared, dy by dx is x squared, so the result is 2 in 2x. If it is x squared, it is 2x. And general rule is that y is equal to x to the power n, suppose any power, may not be 2, 3, 4, like whatever it will be, to the power n. So dy by dx is equal to power into the variable to the power minus 1. So this is the general rule, and this can be verified by taking the difference quotient, as we have discussed earlier. So y plus delta y minus y divided by delta x, which is binomial expansion, then we'll find that dy by delta y by delta x is equal to this when delta x tends to 0. That means when we will go to limit delta x tends to 0, then dy by dx is equal to n to the power n x to the power n minus 1. So here dy by dx equal to limit delta x tends to 0, it will be dy by dx, then it will be 2x. So general rule will have to remember that if there is power, dy by dx is equal to n power x to the power minus 1. This is the rule. Then rule 2, multiplication by a constant. Suppose the function is multiplied by a constant, it is a constant. So y is the function of x, and the form is y is equal to cx squared. So it is a power form, but multiplied by the constant c. So dy by dx is nothing but derivative of the function cx squared is equal to c into 2x is equal to 2cx. That means the derivative without x, what we got without x, without c, without constant, that should be multiplied by the constant itself. Then it will be 2cx multiplied by the constant. Okay. So for example, suppose y is equal to ax to the power b is a power function. So dy by dx is equal to a multiplied by the constant a. So a is the constant, and a power into the variable power minus 1. So this is the result. So this can be verified again by examining the difference quotient depending on the limit. Delta x tends to 0, you will find that dy by dx is nothing but 2cx. It will go to be there. Then rule 3, derivative of a sum. Suppose the function is in the form of a sum, so it will be fx. Y is the function of x, but form is fx plus gx. So dy by dx, that means derivative of this is the derivative of the first function plus derivative of the second function. Derivative of the first function plus derivative of the second function. Example, y is the function of x, and the form is 2x cubed plus 3x to the power 4. So it is in the form of fx plus gx. Okay. So dy by dx is the derivative term by term. So dy by dx is equal to 6x squared. So 2 into power, then variable power minus 1. So 6x squared. So similarly here, 12x squared. So in case of sum, we should derive term by term. So this again, one can see by binomial expansion, examining the difference quotient and limit. Then rule 4, derivative of a constant. So it is always a derivative of a constant is 0. Suppose y is the function of x is equal to c. That means the variable, dependent variable y, increases at a constant rate c. It's always c, whatever may be the value of x, but change in y is always constant. So dy by dx is equal to dc by dx is equal to 0. So this again can be proved by seeing the difference quotient and limit. You will find that dy by dx in a constant function is 0. So outwardly, the derivative of a constant is 0. That we have to remember. So next rule, rule 5, is derivative of a product. Suppose y is the function of x, but they are in product form. Function of x and function of function and second function, fx and gx, they are in product form. So let u is fx and p is gx. Then y is equal to u into p. Then what will be dy by dx? Okay. Now taking difference quotient and limit, we'll find that dy by dx is equal to e into p prime plus p into u prime. This means dy by dx is equal to, putting these values, fx into derivative of gx plus gx into derivative of fx. So this means if the functions are defined, then derivative of the product is equal to first function times the derivative of the second. So first function multiplied by times means multiplied by derivative of the second plus the second function gx times the derivative of the first function. Derivative of the first function. So this is the rule. If they are in the product form, then dy by dx is fx g prime x plus gx f prime x. That means first function multiplied by derivative of the second plus second function into derivative of the first. Now, this can be explained further that derivative of this product, d by dx of this product, is equal to fx into derivative of the second plus gx into derivative of the first. So this is equal to this, the first function times derivative of the second plus second function times derivative of the first. So let us have one example. So y is the function of x, and it is in this product form. Y is equal to x to the power 5 plus x squared into x cubed plus x. So what will be dy by dx? So if we apply this rule, the first function into times derivative of the second plus second into derivative of the first. So what will be the result? So x to the power 5 plus x squared, so it will remain as it is. The derivative of this means 3x squared plus 1. So with respect to x, this power into x to the power minus 1 plus power is 1, so it is 1. Then plus second x cubed plus the x cubed plus x. Sorry, the mistake. Second is x cubed plus x. Okay, into derivative of the first means 5x to the power 4 plus 2x. If we simplify, then it is 8x to the power 7 plus 6x to the power 5 plus 3x to the power 4 plus 2x cubed plus 3x squared. So you can check the calculations. There will be some mistake also, doesn't matter. So it is this. Just you multiply and add. So this will be the dy by dx. So first we have to remember the rule that if it is in product form, it is derivative will be so first function multiplied by the derivative of the second plus second function multiplied by the derivative of the first. So this is the rule. Then calculations will be correct. Then homework one can do this exercise. Y is equal to 3x cubed plus 1 into x cubed plus 2x. So find the derivative of y prime. So what will be? Just same thing, just a small exercise. Next rule is rule 6, the derivative of a quotient. So when it is in divisible form, then what is the derivative? Suppose y is the function of x and it is in this form, fx divided by gx. So let u is equal to fx and v is equal to gx, then y is equal to u by v. Now, taking the difference quotient and limit of delta x, so details you can see in the PDF, and we'll show the results here only. So after taking the difference quotient and limit, we'll find that dy by dx is equal to, so second function multiplied by derivative of the first minus first function multiplied by derivative of the second divided by square of the second function. So if you remember the derivative of a product, it was first function multiplied by derivative of the second plus. Here it is minus, but here it is plus. Derivative of the second function into derivative of the first function. But in case of quotient, this is the formula that second function multiplied by derivative of the first minus first function into derivative of the second divided by square of the derivative. So this is the rule that we have to remember. Now suppose one example. Y is equal to 3x squared plus 1 divided by x. So it is in divisible form. So dy by dx, so if we apply this rule, dy by dx is equal to second function multiplied by derivative of the first, 3x squared plus 1 minus first into derivative of the second divided by square of the second. So we'll have to, we must be careful in writing and putting the sign off, otherwise we will not arrive at the results. So this is simple now. So what is the result? X. And derivative of this is 6x plus 0 is a constant. Derivative of a constant is 0 minus first into derivative of the second. So power is 1, so it is 1 only, divided by x squared. So here it is 6x squared minus into 1 means 3x squared plus 1 divided by x squared. So if we simplify it, it is 6x squared minus, remove the bracket, minus 3x squared minus 1 divided by x squared. It is 3x squared minus 1 by x squared, which can be written as 3 minus 1 by x squared. So this is the result. So we should be careful in multiplication, then removing the brackets and so on, and we arrive at the actual result. So this is the rule of quotient. When the function is in the form of a quotient, then what is the rule of? So we have to remember this. And proof, you can go to the through PDF in details. So next rule is derivative of an inverse function. So what is an inverse function? Suppose y is the function of x, y is a dependent variable, x is an independent variable, and x is also dependent on y. So in that case, x is an inverse function. Okay, that means gy is an inverse function. So suppose y is equal to a plus 2x and x is equal to here you can find out x is equal to half of y minus half of a. So transfer a to left side divided by 2. This will be value of x and y. So the main characteristics of an inverse function is that mapping of x to y and y to x is 1 to 1. So there will be no two results of y or one value of x. we have discussed earlier in my earlier lectures that suppose y is a crop and it is the productivity or production of a particular crop, and x is a labor. So when x one amount of labor is applied to the field, that means x1, say MP, this is labor days applied to the field, then we will get corresponding production level. Now, this is 1 to 1. Now, if labor level is increased, we will not get the same Y, same level of output. Output will also change. So, at different level of X, we will not get same level of Y. So that is not 1 to 1. So when X1 is applied, X1 level of input is applied, Y1 level of output is produced. When X2 level of input is applied, Y2 level of output will be produced. So this is called 1 to 1. This is the characteristics of the inverse function, that mapping of x to y and y to x must be 1 to 1. So each value of x has only one value of y. It's written here. Each value of x has only one value of y, not two values of y. Okay. Suppose the function is defined, y is the function of x, and form is y is equal to x cubed. So first derivative, dy by dx is equal to 3x squared. Power into the variable to the power minus 1, that is 3x squared. Now what will be x from here? It is the cube root of y. And we can write y to the power 1 by 3. So one characteristic of the inverse function is that the derivative of the first function and derivative of the second function, should be equal to 1. So dy by dx is equal to 3x squared, and dx by dy is equal to, from here, so power into variable to the power minus 1, that means minus 1 by 3 into y to the power minus 2 by 3, and 1 by 3 into, for y you can write x cubed, because y is x cubed, to the power 2 by 3, and this is nothing but 1 by 3 x to the power minus 2, because when power is 3 and to the power again minus 2 by 3, so when you multiply, this becomes minus 2. So this is equal to 1 by 3 into 1 by x squared. So dy by dx into dx by dy, it must be 1. So dy by dx we have got 3x squared, and dx by dy we have got 1 by x squared. So when this is multiplied, so the 3 will be cancelled, x squared will be cancelled, limiting is 1. So the multiplication of the derivative with its inverse derivative of the inverse function is always 1. Now example, suppose y is equal to x3 x to the power 3 plus 4x is equal to 3x squared plus 4. Then dx by dy, we can find out. Now in this, it is a special type of function that dx by dy is simply 1 by inverse of this. That means reciprocal of this 1 by 3x squared plus 4. And dy by dx into dx by dy is equal to 1. So this is all about the derivative of an inverse function. So our derivatives will be correct if their multiplication, derivative of the main function along with the derivative of the inverse function is equal to 1. So it must be 1. Next we will discuss rule 8, 9 and 10 in my video part 2. Thank you very much.